So again, before we start, the Coastal Institute of Archaeology at UCLA acknowledges the Gabrielino Tonga peoples as traditional land caretakers of Tabangar, the Los Angeles Basin, and Southern Channel Islands. As land-grant institution, we pay respects to the Hunukbetam ancestors, Ahiri, Hiram, elders, and Eyohim Kem, our relatives, relations past, present, and emerging. And for those of you who are here, this is Dr. Melgar. He earned his BA in Archaeology from the National School of Anthropology and History in Mexico, and an MA and PhD in Anthropology from the National Autonomous University of Mexico. Since 2004, he has been a full-time researcher at the Templo Mayor Museum. Dr. Melgar's research has been awarded the 2010 Alfonso Caso Award for Best Bachelor Thesis in Archaeology, the 2011 Teotihuacan Award for Best Essay on the Materials of that City, and the 2019 award of the Mexican Academy of Sciences for the Best Young Researcher in the Mexican Humanities. He has written 5 books and more than 80 articles for domestic and foreign publications. In his new book, Lapidary Objects from the Great Temple, Styles and Technological Traditions, received the honorable mention in the 2024 ENAC Prize for the Best Archaeological Research in Mexico. So thank you for being with us, and go ahead.
Thank you so much, Matty. Well, I want to thank Lisa. She couldn't stay with us today, but thank you for this opportunity to share my expertise and the kind of analysis that I perform on different kind of rocks and minerals among Mesoamerican cultures, but also beyond that, I also analyzed turquoise pieces, mosaics, inlays from the American Southwest, also from Central America, from Costa Rica, Panama, also from the Andean region. So I expanded my topics and assemblages that I handle by sourcing the raw materials and the manufacturing techniques. No, how we will have this workshop? Well, the first part we will discuss with you the advantages and limits of different techniques to sourcing the raw materials, and after that I will handle the biggest style that we have in this sample of object from the Coxen Institute, the famous Mezcal style pieces from Guerrero State, and after that we will have a little break, and after that we take a look on discussing the other obsidian and recent objects that I proposed from where they could come from, not only by the raw materials, by the manufacturing techniques. So I will show you some details that we could take a look with this dynamic microscope, but also I will show you how I perform or cast the replicating molds with a special polymer tape that with that I could replicate with a greater fidelity or accuracy the microtopography of the pieces, and I could move, not the objects, these molds, and covering them with gold ions or called sputtering, and analyzed under high vacuum mode in the scanning electron microscope. With that is the best way that I could identify, like fingerprinting the manufacturing techniques, because I also have more than 20 years of experimental archaeology workshop on lapidary objects. So I have more than 700 experiments replicating pieces also to prove the techniques that different pre-Hispanic cultures employ to craft these objects. Common objects, votive objects, jewelry, among others. So that's the kind of stuff that you could see today, and also I will show you in this sample of pieces how could I prove or propose from where they came, despite we don't have the complete or the whole information of the context and the site that they could come from. So I could recover this info by the type of analysis that I perform. So this what the workshop is called, in agreement with Lisa Stapleton, the Archaeometric Analysis of Ancient Mexican Lithics, Identifying Raw Materials and Methods of Manufacture. And well, the first issue, or the first topic that we will cover today is about the prestige goods. So it's common among Mesoamerican cultures that they employ different shells, rocks, minerals, feathers, that also metals, that they consider them valuable, prestige, or coming from sacred places. So that's the reason, if you could see, they also prefer especially the greenstones, also feathered with greenstone hues, and sometimes golden pieces mixed with greenish, bluish stones. So that's the reason they are obsessed with these colors. But there's one main issue about characterizing or identifying the pieces by colors, because a lot of scholars propose a priori or without any data that almost all of the greenstone pieces are jade or jaded. But jaded is a type of mineral from metamorphic origin that is a mineral with a high amount of sodium, a silicate with a high amount of sodium, but the other greenstones like serpentinite, it's a silicate with a high amount of magnesium, not sodium. So we have different chemical elements to identify them, despite they came from metamorphic origin. We have also listonite, like this one. It's like, for simplifying the process of formation of this rock, it's like a serpentine or a green quartz metamorphized and weathered. So it has some characteristics of serpentine, but others with quartz. So it's a really complicated rock to identify. But also we have secondary minerals like malachite from the copper, that it's like a greenish onion layers of a rock. But also we have igneous greenstones. Igneous. Not all the greenstone appearance came from metamorphic origin. For example, granodiorite and diorite, we have some diorite pieces here, are from greenish lavas. So you never expected that greenish colors also came from igneous rocks. So that's a problem that geologically, metamorphic or igneous rock came from different sources, so that complicated our sourcing analysis. But that's the issue about the raw materials. We have complicating our research with the identification of styles by morphology or aesthetics. Because a lot of my colleagues thought that if the objects have attributes or iconographic motifs like the Olmec, like a jaguar mouth, or a bilateral symmetry like Teotihuacan people, these seated persons with closed eyes like Mixtec pieces, the schematic objects like the Scala style in Guerrero, or with the headdresses of the snake serpent like this Mayan object, or with the twister nose in the case of this rain god from central Mexico. We have a Mexica object, but the appearance is not enough to identify the styles, because sometimes they emulated the styles. It's like in modern times, you could see here in US, for example, a lot of 19th century buildings that resembles a classical from Greeks and Romans buildings, but are neoclassic. Copying the columns from Doric columns, Ionic columns, but they didn't craft or build them 700 BC. They are from 19th century, so that's the same. We have, maybe they look like Olmec, like Teotihuacan, but they didn't came from formative or pre-classic times, classic times, or post-classic. Sometimes they are emulations. And another problem is, well, with iconography, we could propose Mayan pieces, but what happened with pieces without any diagnostic iconography? Well, by technology, we could track from which style, which technological style, with pieces with iconography, if they match the same techniques, maybe these objects, for example, these are Mayan pieces, these objects could be Mayan crafts also, because they share the same sequence of production. And, well, how can we study the ancient technologies? Well, I try to analyze them by raw materials, the working tools, the manufacturing traces, to identify the chain operatoire or sequence of productions and the graph specialization. How can we identify and distinguish attributes, diagnostic attributes of styles and their function, the circulation and distribution of these objects, and if they are local or foreign technological styles. So I will show you how can we do that. Well, but remember the first part of this workshop we will discuss some of the provenance techniques for identifying the raw materials. For example, the EDS, the electron microprobe, the micro-Raman spectroscopy, the X-ray fluorescence, the thin section petrography, and X-ray diffraction. I will talk more in depth in the following slides. But, for example, these are one of the most common techniques to identifying or sourcing raw materials, but we will obtain different quality and they are better or will offer better results in a specific raw materials and rocks or minerals, depends on what we want to know about them. Because, for example, some of the techniques are really strong by analyzing the chemical elements, but not the molecular bonds or compounds. Others are really specialized in the molecular bonds, but we don't know which of the specific chemical elements they have. And other ones we could identify the type of inclusions or formation of the crystals or the crystallographic phases. So we could identify these different kind of info. And well, we will start with the EDS or the energy dispersive X-ray spectroscopy. I don't know if you employ this technique or know something about it. Some of you employ this technique. And which kind of info you obtain with this one? When you employ it, what kind of data you obtain with this technique when you employ it? Despite it could be not in rocks, but in the materials that you employ it.
Elemental?
Elemental, yes. But this elemental info is the same that you obtain with, for example, portable X-ray fluorescence with the same sensibility? No, because it's part per thousands, and XRF fluorescence or X-ray fluorescence, it's parts per million. So it's not strong for trace elements, but it could be very good for major elements, and specifically, for example, if we want to analyze pieces that maybe could be jaded, this technique is better than X-ray fluorescence. Why? Because X-ray fluorescence, portable or in situ, sodium is in the edges or the equipment is blind to identify sodium. But with the EDS, sodium is one of the key elements that you could analyze to identify if the rocks or minerals have it. And because it's part per thousand, you know that it's a real major constitutive element in the material. So sodium is a key element. You can see here, for example, this is the spectrum from an archaeological piece that I know is jaded. How I know it's jaded? Because if remember, it's a silicate rich or aluminum silicate rich with sodium, and in the case of this is green emerald. It's not imperial green jade, but it could be imperial green jade. We have chromium. In EDS, chromium could be identified, but sodium is the key element. And this is my reference sample. I bring two of them from Ottawa Valley that they have silicon, aluminum silicate with a high amount of sodium and chromium. So you can see it's quite the same spectrum, but one is my sample. This is more than 500 years old object. And with this one, we could identify pieces with that they are jaded or real jaded, because we could identify sodium or magnesium. And remember, with XRF, sodium is in the limits, sometimes the equipment is blind to identify sodium. So this technique could be a good one to identify jades, for example. Also, in comparison with X-ray fluorescence, if you employ X-ray fluorescence, you know that you need a specific minimum size of the object that you could, because of the window that the X-ray get out to analyze the pieces. If you try to analyze little or smaller pieces, X-ray fluorescence couldn't work. But with EDS, you could do only in a micron square or nanometers with a high spatial resolution. It's non-destructive, it's fast, also we could attain elemental mapping. But there are some limits. It's not as excellent as we expected. You could say needs close contact to the materials. It couldn't analyze huge pieces because the sample chamber couldn't allow pieces more than 20 cubic centimeters. So, for example, this is one of the biggest pieces, a greenstone jar from the Texcoco Lake, from the Alcoloapan region, that I analyzed with this. Another limit, remember, it's parts per thousand, so it's not as powerful as parts per million, like XRF. It couldn't go below or beyond 4 microns, so it's limited in depth analysis. Remember the sample size. We couldn't allow bigger pieces. It's non-portable. And also depends on the material. Sometimes could have some issues with charging, especially with non-metallic pieces or materials. So that's a limit. But remember, one of the best techniques to identify shade. We have the other famous technique, the XRF, especially the portable XRF. If you employ it, one of the best advantages is it's portable, so you could analyze wherever you want the size of the pieces, but we need a minimum size of the objects. It's non-destructive, sometimes contactless. It's really accessible with parts per million, and it's ideal for trace elements analysis. But you could see here, we could analyze no problem with the huge or the bigger size of the pieces, but also we could compare directly the one reference sample with the archaeological piece, and if we have quite the same spectrum, we could suppose that they are the same raw material, one model or geological reference and the archaeological. And if we analyze a lot of the assemblages or pieces, we could see if they have the same trend. No? But again, we have limits. We couldn't analyze tiny pieces below a half of centimeter, cubic centimeters. They cannot detect light elements. Remember, one of the key elements of jade is sodium, but sodium, aluminum, and phosphorus, almost a lot of the portable X-ray fluorescence equipments are blind. Or you need some devices to increase the detection, but the technique is not ideal for especially sodium analysis. The problem is, well, it's very good for obsidian sourcing, but for greenstone sourcing has a lot of problems because they are heterogeneous and complicated the sourcing analysis. Also, the problems about a lot of time with the exposition or the people that handling the equipment with radiation. And another one problem is if you have or don't have standards or certified materials that you calibrate your equipment. If you didn't have it, well, you could analyze a lot of pieces, but in comparison with what? So that's the problem that a lot of people thought that the portable X-ray fluorescence, it's a magic equipment and you could analyze anything. Well, have some issues to exploit. So we have a complementary technique because in my opinion, we need at least one chemical analysis equipment and one molecular analysis equipment. Because with the former techniques that we talked some minutes ago, they offer us or give us chemical composition. But this technique is not from chemical composition, it's about molecular bonds and compounds. So the micro-Raman spectroscopy, I also employed portable Raman spectroscopy. We could identify these molecular bonds and compounds as the EDS, high spatial resolution, microns, not like portable X-ray fluorescent that it's close to 1 centimeter. It's non-destructive, non-invasive. We have equipment portable and non-portable. The advantage of non-portable is that you focus with a microscope, so you could have a better result with the non-portable equipment. Also depends one important issue. I don't know if some of you already employ Raman spectroscopy. Some of you employ this technique. One important issue or key element is the color of the laser. Because a lot of people think, we employ red laser. But we have 3 colors. Depends on you if you want to analyze organic or inorganic materials. For example, red is for not everything, but it's like for all purposes. But if you want to analyze organic materials, you prefer purple. And if you want to analyze inorganic or rocks, could be better the green laser. So I employ better, or I have better results in almost all the rocks with green laser. But it's interesting that in amber, in jet, and in turquoise, I obtain better results with purple laser. So it's not always applied this pattern, but the color of the laser is very important in the case of the micro-Raman spectroscopy. And also we have some quantitative analysis of the compounds. So I show you, this is the micro-Raman spectroscopy that I employ. You could say I focus with the microscope, but it's really like the EDS, close contact. It's contactless, but really you need to put close to the objects to analyze them. And here, for example, I have in red my reference sample of green quartz. You will handle later these samples that I have also the archaeological materials, green quartz from a Guerrero state. And a lot of archaeological pieces that you could see quite the same molecular bonds. This is the high peak of silicon dioxide that is related with quartz, chert, and all of these rocks and minerals that are rich with silicon. But this is another spectrum, totally different, despite it's quite the same color, green quartz, green serpentine. This came from Tehuantzingo, one of the famous sourcing or builders employed by the American cultures. And we have pieces from Teotihuacan. And you could see totally different the peaks. The position is close to 500 in Raman phenomenon. Here we have at least 4 major peaks, but this is the one of the most important because it's the molecular bond of aluminum silicates. So remember, this is a silicon dioxide, green quartz. The serpentine is a aluminum silicate rich with magnesium. But this is not magnesium alone, or silicon or aluminum. It's aluminum silicate con molecular bonds. And depends on the other peaks, we know from which of the sourcing or the boulders they came from. And you can see it's quite the same, all the pieces with my reference sample. So we know not only is serpentine from Tehuantzingo, these pieces came from this boulder specifically. But we have another molecular technique, the Fourier transform infrared spectroscopy, or FTIR. It's quite the same, the purpose of Raman spectroscopy. Again, it's non-destructive, the advantages, high spatial resolution. Here we have also qualitative information. And like the ramen, we have organic and inorganic materials, and it's portable. So you could see, this is in Templo Mayor, we analyze tiny or bigger pieces. No? It's like a projector, the projector like we employ for the computers or laptops. And here again, you could see, it's a different info. My reference sample of geodate and archaeological pieces that share the same spectrum, or the serpentine pieces with archaeological pieces with the same spectrum. So with that, we could compare and certify which pieces show the same spectrum, but again, we have limits. One of the main issues is FTIR couldn't analyze, for example, which one? For example, this one. It's really difficult to analyze the face. I could analyze the back part because it's flat, but this, because it's so rough and irregular, the technique couldn't allow in contact with it. Requires crystal contact, but one of the problems is wave interference, and sometimes, for example, I have a lot of problems with whitish materials. The FTIR reflected and saturated the signal, so it's not really good with whitish materials. Limited sensitivity, and also if you have, for example, if I analyze this greenstone, these parts with cortex, the FTIR couldn't handle or give me very good results with weathered materials and special oxidized materials like weathered pyrite or materials from mosaic mirrors, for example. It's not a very good technique. And also I employ more powerful techniques, but have also issues, like proton-induced X-ray emission spectroscopy, known as PIXE, with the complementary technique Rutherford backscattering spectroscopy, or RBS. And you could see a lot of detectors, and these are pieces from Templo Mayor, for example, one mistake penalty. And we compared our sample from Motagua Valley, not in this object, with some beads and pieces with Mayan iconography, and we confirmed they are real jadeite. This is the kind of spectrum that you obtain with PIXE, and this is the kind of spectrum you obtain with RBS. But we have some advantages: high sensibility, non-destructive, a wide elemental range. Remember, XRF couldn't identify, or with good results sodium, here we could identify them. But, and also high spatial resolution, really we could know layers of the composition of the elements of the outer, for example, in these objects. I could identify or analyze the cortex and the inner layers. But some of the limits is in situ. This technique, if you know this weapon of the Death Star of Star Wars, like that one, a huge one, to accelerate the protons and focus the signal of the energy of the protons. So it couldn't be a portable technique. Less effective on lighter elements like XRF. Sometimes the sodium and lighter elements like fluorine, we couldn't identify with good results. Sometimes you obtain another info about the background materials. You need a sample preparation or fix the pieces without any movement, because it's so sensitivity that if you move, for example, in this object, and the laser and the position moves from the greenish layer to the whitish layer, I obtain a really complicated spectrum. But there's something that a lot of people didn't talk to you about PIXE. Because remember, it's an acceleration of protons. And what happens if you employ it on some materials that could be deteriorated by photoluminescence? Look what happened with turquoise. It damaged it. And after months, it still some of these points of analysis. So pieces that you have in the exhibit cases, oh my God, if you employ pinset for turquoise, please don't expose these pieces too much because you could, it's not burning them, but really you could appreciate that you employ pixel on them. And we're almost finally finished this part of the workshop. Thin section petrography. It's like the classic geology technique that we could identify easily, what was some experience, the mineral composition and microstructure of the pieces, the textural features, like for example, this is a jadeite and this is serpentine in section. But you could see it's glossy and this is fibrous appearance because this is the formation of jadeite with a rich of silicon and sodium, and this is magnesium and silicon. And it's portable and you could move the material. But limits, to do a thin section you need to cut your sample. So, well, modern ones, no problem. Imagine I need to drill at least 1 cubic centimeter to obtain it. So a lot of people, I don't think they want to, that I could them. You could analyze them, and one problem is the sample preparation, not very fine-grained materials you could analyze, and for example, some materials like lutite, mudstone, and fine-grained materials, these techniques, you couldn't see anything from them. And you need experience or working with people with a very good eye to identify the inclusions of the minerals among the rocks. And finally, we have the X-ray diffraction. This is one of the best techniques, also destructive. Advantages, you could determine the amount of the minerals and the presence of them. For example, in the order the XRD show you the results, you could know that this is, for example, the main mineral composition, jadeite in this. And you have, in less amount, quartz or polyethylene. This is a key element if you want to know if they came from Motagua Valley, because there are some inclusions that came from that part of the world. If you analyze jades from Myanmar, from Burma, you have another kind of secondary minerals. You could identify crystalline phases, the crystal structure, and in high precision. About the atomic arrangement of limits. Not all the equipment, but normally it's a lab analysis. You need to drill the materials, not normally, obtain 1 centimeter, cubic centimeter, smash it to avoid the different reflection of or diffraction of the material, and it's less effective in amorphous materials. For example, for obsidian, that it's a glass material, you couldn't obtain anything because obsidian is not crystallographic. Also, we have issues with the orientation of crystals. It's an invasive destructive technique, and we couldn't analyze depth profile information. So you could see we have advantages, but also disadvantages or limits in all of the techniques. So depends what kind of rock or mineral you want to analyze. You could spend or employ and obtain better results, depends on what you want to analyze. Any questions before we're moving? The technique. Now, how can we identify the materials, and we could propose some of the stones or raw materials on this example added from the Hudson Institute. Well, we need, preferable, have your own reference collection of rocks and minerals in the institution or personal. But it's better if you have certified reference materials to calibrate the equipment, but also to confirm with the different techniques that the rocks, the minerals that you propose, this is jadeite, this is green diorite, or this is gneiss or skarn. It's better if you have, for example, mica schist, serpentinite, or granodiorite. It's normally with a lot of my colleagues that they have basalt or obsidian as a certified material, but I bought these other certified materials to identify metamorphic and igneous rocks, but not the common obsidian. And you can see these are some samples of the reference collection that we have in Templo Mayor Museum, like fluorite, serpentine, different colors of jaded from Ottawa, serpentinite from Tehuizingo, green quartz, green quartz that looks like jaded, azurite and malachite, fuchsite. I have one of these pieces of blue jadate, almost blue jadate, different colors of turquoise, for example. But it's better that not you're buying the samples in a mineral store. It's better if you obtain them directly in the fieldwork and not bubbles or pieces on the streets. You need to extract freshly, directly from the walls of the boulders. For example, this is serpentine with jadate in one part of the Motagua Valley. These are some mines in Chalchihuites region. We have these skarn and metamorphic rocks in the close to Puerto Escondido in Oaxaca. Also, I reference all my samples with GPS. This is the Potosí Huastec that I analyze and sourcing calcite, limestone, and sandstone among the Tamuín region in El Abratanchipa. And this is some of the rocks and minerals that I have in the collection, reference collection in Templo Mayor. We have amazonite, jet, calcite, quartz, schist, gneiss, granodiorite, specular hematite, jadate from Guatemala, marble, mica, obsidian from different sources, pyrite, slate, serpentine, skarn, travertine, turquoise, among others. So we have also the Geology Museum of National University of Mexico, when we did one temporary exhibit about jade and turquoise objects. They want some of my samples because I have a better reference collection than others. But I also analyze the reference collection that we have in Templo Mayor, when we employ a lot of these techniques that I showed you and doing some statistic analysis of them. With Euclidean distance analysis, ternary plot, you could see, for example, these are jadate, these are serpentine, and we have different jadates and aluminum silicates rich with more magnesium, with more sodium, jadate, more magnesium, serpentine, for example. And more silicon, quartz. Also, we overlapping turquoise pieces from Templo Mayor, and in each color, turquoise from Arizona, turquoise from Nevada, turquoise from New Mexico boulders, turquoise from Colorado, from Baja California, and Sonora. And you could see, Baja California, we don't have any turquoise came from that sourcing areas. These are from Sonora, but mainly they came from Arizona and New Mexico. They overlap in some of them. And also we could identify pieces with jadate, with green quartz, with serpentine, we also have a lot of green stones, but we don't know what they are. The Mexica love to collect whatever has green. But we know which are some minerals and rocks, but they also like unknown rocks and minerals. And also, remember, one of the best techniques to analyze obsidian is XRF. We have sourcing areas that in obsidian jewelry from Templo Mayor, we have not only from Otumba, Boulder, we have from the subsource Buena Vista. We identify doghead pendants with great translucent obsidian came from Pico de Orizaba. We have pieces from Ucaeo, and the majority of them came from Pachuca, the green golden obsidian that we will see later in the workshop. And this is the second part. I will talk about the techniques I employ before we're handling some of the materials and before the break. My expertise is more than 20 years about manufacturing techniques and traceological analysis. And since 2004, I have an experimental archaeology workshop on rocks and minerals that we employ serpentine, jadeite, schist, green quartz, among others, to replicate the modification of the pieces. For example, also the pumping drill, and we have different studies among these years that you could see we're employing the tools, the techniques that we follow by reading sources, archaeological context, proposal of other researchers, and ethnographic studies. So we compare, despite this could be with modern tools, the issues and problems that they have when they're crafting obsidian or other materials. These are from different archaeological sites, and the tools that we have, the negative of braiding jadeite, in this case from Yaxchilan in Chiapas, the pumping drill, and also with different slab stones. We try to analyze with a lot of different origin of the materials. Volcanic materials, sedimentary materials for braiding, obsidian tools, chert tools, petrified wood tools, cactus spines, animal spines like porcupine, rabbit and deer pelts, different types of abrasives, different sizes of diameters of reed, quartz crystal, among others. And each of the more than 700 experiments that we have will register with a lot of detail all the materials, and from the beginning, working and the final result of the experiments. And to characterize the manufacturing traces, we employ optical microscopy with digital microscope, a Keyent microscope, a dynolite microscope. We also have some 3D reconstruction of some drill holes, but the best technique to characterize, like fingerprinting the traces, is the scanning electron microscopy with the same amplifications. And I will show you later today how I cast these molds, because we have the dynolite here, or optic microscope, but with the scanning electron microscope, how can we move these pieces to analyze them? Well, we could avoid all the bureaucratic permits moving the pieces by doing these molds, casting these molds, and you could replicate whatever object you want, and with that, I could move. It's like the dentists. They didn't craft or do your brackets directly in your mouth. They made a mold of your teeth. That's the same principle. And with that, I also know the other technique, and some colleagues employed a silicone paste, but I don't like it because it's greasy, and sometimes if I employ in this kind of objects, they'll obscure and add some grease or oil on the object. So it's really what the restorator calls it, a scream if I employ this silicone paste. But my technique, if they didn't see me taking them out or casting them, they didn't notice that I did. So it's better our tool. And these are some examples with my colleagues. For example, Juan Carlos Melendez in Guatemala, analyzing the inlays from Tikal burials. René is analyzing the famous obsidian base, spider monkey obsidian base. Señor de las Limas by Henri Bernard, in a famous piece from Armec region. Hervé Montero is analyzing the huge beheaded head of Coyolxauhqui goddess. Or with Adrián Velázquez, we're analyzing the famous jaguar front from Chichen Itza, or I have analyzed all the burial of Kirish Pacal from Palenque. But also we could analyze like the headdress of the Red Queen from Palenque, or huge monoliths like the Coyolxauhqui or the Moon Goddess from Templo Mayor, and also that here we are starting the analysis of the manufacturing traces of the sunstone. So imagine that you could cast whatever you want with our technique. And this is a sample of more than 50 sites and more than 100,000 pieces that we analyzed with this technique from the American Southwest, ancient Mexico, Guatemala, Costa Rica, Panama, and so. And remember, I will show you, this is the site that you could see directly when I cast the molds. After I cast the molds, I cover them with gold ions or sputtering them, making them materials with conductivity, and at the scanning electron microscope, because if you don't know these kind of microscopes, you could have 3 different views or modes. Normal microscope, low vacuum scanning electron microscope, and high vacuum. What's the difference? High vacuum microscope or mode is like if you have channels with high definition, that's high vacuum. But you need that the material has conductivity. So if I cover with gold, I could analyze them in high definition. And because I analyze in microns, a thousand of a millimeter, imagine if I analyze them in high definition. So it's better, my molds, than the pieces. And to show you the potential of them, this is optical microscope. You could see my experiments, cutting with obsidian, cutting with turquoise. Quite the same. It's like you're doing, taking a ticket for the lottery, but with a scanning electron microscope, same, different. Despite you couldn't measure the size, it's tiny, irregular lines, flat surface with straight bands, parallel bands. With that, you can fingerprinting the techniques. Obsidian, sure. Quite the same, totally different. But that's not all. We're comparing by one in pairs, archaeological pieces, my experiments, and you could see more than 500 years ago, my experiment. Quite the same, like twins, but they are not twins in the same time of crafting them. And we compare and crossing pieces, supposedly from the Mayan region, pieces from the Mayan region, my experiment, and with the same appearance and with the same traces. So I could track from which style, from which site, time period the pieces came, and which are local and which are foreign in the assemblages with archaeological context. But to prove that, also we replicate the pieces with these techniques and confirm sometimes which are the original and which are the replica. In this case, for example, we replicate a Teotihuacan Guerrero style or Teotihuacanoid style pieces from Teotihuacan, from the excavations of Linda Manzanilla. But she requested me, how can I identify that is not original one from Teotihuacan's times? Well, she requested me to employ a non-Mexican slate because only the sourcing material is that you could prove is not a Mesoamerican object. Because I replicate all the techniques on one of her figurines. So she's worried if someone steal me the object and selling, but only the source of the slate could prove that it's not a Teotihuacan object. But if you employ transgeological analysis, it has the same techniques of Teotihuacan pieces. And I will show you some examples of new techniques that we employed since 5 years ago to increase the register of the manufacturing techniques and the order of the decoration of the incise designs. Is the reflectance transformation imaging, RTI analysis, and I will show you some examples that I have of pieces among not only from Templo Mayor, but also famous objects, that in a black room you put a fixed camera and with different angles of the light you take photos. It's not like photography that you're moving the camera. Here you're moving only the light source. And in like the movement of the sun, you with different angles, you try to obtain, we take more than nearly 50 photos. My scholars normally take 20. We took 50 because more photos in different angles, we could obtain better results for, I will show you the kind of results. For example, these are pieces like from, we have some pieces here, Teotihuacan or Mezcal style, Mayan and Olmec. This is the common photo. And this is one of the filters with RTI. So you could increase the iconography, but also you could see which of the designs are first or were first. They first did this triangle of the nose and the mouth, and later they did these horizontal lines. Sometimes they did the division of legs, the trunk, the head, and after that they put the line for the arms. So we know which of the designs they did first, later. Sometimes you couldn't identify the iconography and some mistakes working there. And you could see also multiple drill holes to produce the eyes of the, in this case of this Olmec. And also we try to identify if there are some landmarks or measures to craft the masks or the faces. So we put geometric morphometrics, and you could see in nearly 400 pieces from Templo Mayor, we have, each point is one of the pieces. You could see that despite we have nearly 400 pieces, we have only 5 landmarks in masks and 3 landmarks in figurines of, in this case, 8 patterns, maybe styles, working groups, artisanal schools, crafting these 400 pieces. 400 pieces, but we could clustering them in 8 groups. And also it's interesting that a lot of people thought that 300 of them are Mezcal style, looted pieces from Guerrero State. Yes, the Guerrero State pieces from Guerrero collection are here. This is the Templo Mayor assemblage, and you could see a minor group matches the sizes and facial attributes of Guerrero State, but the majority of the Templo Mayor collection is outside the Guerrero style pieces. So they are emulations. And to prove that, you could see the Templo Mayor pieces are not only tiny as Guerrero State, they escalating the size of the pieces. Not only in figurines, you could see in the masks, the same facial proportions. So, for me, amazing we identified. And now we're going through the more interesting and ludic part of the workshop, handling the materials, trying to discuss the materials and the techniques. Before we're doing the break, we will talking about half of the materials that are maybe Mezcal style. So, how can we identify which style and provenance of this part of the sample that we have here at the Gotzen Institute? You as me and like me are the first ones that handle and propose from where they could come. If well, there are some scholars that I know them that work in Mexico, so maybe they propose from where these pieces came from. But I will show you that not. Remember, as I started, not the appearance is enough to identify the provenance. So, if you know something about ancient Mexico pieces, from which style and region they could come from. A lot of my scholars propose they are Mezcala, and all of them from Guerrero. Really, Mezcala? Maybe Mezcala, but really from Guerrero, and from which period? Because Mezcal style is from formative, like contemporary to the Olmec, 1000 BC, until the arrival of the Spaniards. We have these Mescal style pieces in the 15th century, AD 15th century. So, from which time period, from which part of ancient Mexico? You could see more or less schematic. In this case, this is a characteristic mask with pronounced noses that a lot of my scholars, the other scholars propose. This is one of the subtypes of Mescal style called Sultepec, but Sultepec is in the Matlatzinca region, and I think it's not really Mescala because it's related with Matlatzinca and Azteca Tres church. So really, really late in the development of Mescala culture. And but the other ones, we have smaller pieces and bigger pieces. Do you think they came from the same time period and from the same culture? No, because maybe these ones, the tiny ones, that grab from greenstone axes or cells, came from pre-classic times, but these ones maybe are from other time period, and I will show you some twins or similar pieces that are not from Guerrero. But another problem, remember, greenstones, but not jade. Jade. Almost like only this one. This is the only piece that I think it could be jaded or jaded. Why do you think it could be jaded or jaded? Maybe why it is not green serpentine, green quartz. Why it could be jaded? Or why you disagree with me? It's not jaded. Why do you think? You could stand up and take a look, and you could see some of my samples, reference samples, to compare them. If you want to handle it, remember we will start with the Mescala issue.
So happy.
Yes.
They're beautiful.
And this is the sample. Why this could be jaded, and why the other ones, the Mescala style pieces, are not jaded. And you could, yes. This is serpentine. This is jaded. What it has that serpentine didn't.
Do you want to come here and touch
Yes.
that? So different.
It has.
Is serpentine have the same hardness as jade?
No,
Not quite.
it's softer. This is
Right.
tough.
Feel like
So starting maybe with that,
Yes.
comparing the hardness.
Yes. One. If the restorator colleagues saw you doing this, they could scream. But one of the, I could have one of them. Only one. Only one.
Do you want one?
Yes, only one. Jade, again, jade
It seems so.
sounds like metal. No.
That means that's cool. It's very
Remember, if you're going or seeing some films in South Korea, Japan, and China, there are huge bells, and the bell contours are jaded. And jaded swords, because real jaded. No. Wow. No jaded. Jaded.
It also speaks to our empiricism. When we think about empiricism, it's all five senses, but we're very visually focused.
Yes, exactly. And the other one is, it has oxidized by iron cortex. Jade that has that feature. Serpentine never. So, it's oxidized without smashing it or cleaning it. Jade. Let's say sensory. Yes, info that only handling the materials you could
It's
identify.
all kind of waxy.
Yes. That. But what's in these materials? They are green, but they are not jaded. The problem is that we have igneous rocks and we have sedimentary rocks.
Oh, which ones? Which?
This is igneous. This is diorite. And green, black. Remember, not all greenish are metamorphic.
Also, you don't get the spotty shaded pieces.
Yes.
It's a little bit more linear, the
Yes.
variation is linear rather than spotty.
Exactly.
What are the hardness of these
Ah.
different
The depends, these are softer, these igneous rocks are harder. For example, not alabaster. The difference of alabaster with travertine is the alabaster is gypsum. So it has sulfur and in Spanish it's yeso, sulfato de yeso, sulfur with gypsum. But this is calcium carbonate rocks. No sulfur, not gypsum. It's only calcium carbonate. And it's not from Tecali. Because Tecali is a famous town with this kind of rock, but it's not the only source of this rock. And it's a really bad mistake that all of these translucent whitish material, you call them Tecali. Because Tecali is only the travertine of a specific color from Tecali stone. And this banded material with some greenish appearance came from the Mixtec Puebla, from Tezcala and close to Tehuacan city. That's the origin of maybe this travertine.
Those are the source in Baja.
Yes, see, exactly. There's a lot of
Is that travertine or?
maybe travertine, but also you need to do some analysis because maybe it could be marble. Marble has the difference of travertine and marble. Travertine is a sedimentary rock, so we see the layers or the bands, and it's amorphous. Marble is the metamorphic version of this. This is a sedimentary rock. Marble is the metamorphization of the travertine and the increase of the size of the grains. So it's like if you're looking sugar squares or huge grains of salt. That's the difference. If you see the grain of the material, it's marble. If it's banded, travertine. The same rock, but different origin. Sedimentary, metamorphic. And how we know these are more sedimentary? Because the sedimentary pieces has inclusions in general or with the same color of matrix or background. The sedimentary rocks are more like this one. But if you have different spots, especially these quartz eyes, like this is the whitish spots, these are more common in lavas. So, and they are heavy, despite the size. They are tiny, and it's like this one, because igneous rocks are more dense rocks.
Yeah.
So for me, these are igneous rocks, maybe sedimentary rocks, but
I don't think we need the equipment now because you all these
But-
ways of seeing.
from Guerrero or from which region? So that's the clue. These are the common with contextual origin pieces from Mezcala style from Guerrero sites. You could say they are tiny, less than this. Maybe the biggest one are like this. So I only, maybe this could be Mezcala style from Guerrero, this size and rocks outside Guerrero style pieces.
So you have a lot of andesite.
Yes, this is the results of my methodology.
Is
And-
that a common stone in Mesoamerica, andesite?
Only for working in central Mexico. But in other parts, they employ limestone, sandstone, other rocks. They employ or andesite or basalt. That's the.
That's hard to carve, but
Yes.
beautiful carvings you can have.
So they employ, you could see, in Guerrero State, they love andesite and chert for this coating and sizing. But in sites that are more related with epiclassic, postclassic terms. The earlier ones Teopantecuanitlan, Oxtotitlan, they employed obsidian. So we could identify, if I cast the molds and I identify cutting with obsidian or cutting with chert, I could identify if they came from formative times or epiclassic, postclassic times. But what happened with this? You could see, especially this one, Xochicalco. And in Xochicalco we have nearly 1,000 pieces, and I analyzed them, and they employed basalt, obsidian, and polishing with chert that is not common in Guerrero state pieces. So for me, at least this one, and maybe these ones, came from Xochicalco.
Wow.
See, yes.
So when we talk about sourcing, usually we're talking about the raw material for the pieces. But given that each one of the, for example, abrasives and
Just the
things that
techniques
different-
increases the problem.
So do you see evidence of the importation of certain kinds of abrasives, materials for manufacture
Yes.
that are maybe more optimal for working things?
The problem with the abrasive is that archaeologically it's difficult to recover the abrasives, but the other tools I could identify that they imported foreign rocks. For example, in Xochicalco, we have, despite the hills that Xochicalco was built, are limestone and chert, but we have a lot of slabstones of basalt that came from the bottom of Tembembe River. So they brought boulders and pebbles from more than 100 meters below,
Wow.
moving them to craft metates or slabstones, and only for the architecture they employed limestone parallelepipeds. But they imported the obsidian because the close source is Pachuca and Ucayali, hundreds of kilometers away. So they imported hundreds or thousands of obsidian blades for crafting the materials. Because we have finished pieces, but we have also pieces in process of manufacture.
Yeah.
So that's the reason. And you can see, especially this one, also with the size.
Yeah.
Remember, huge ones. And you see, quite the same stones. So that's the reason that, sure, a lot of people came from Guerrero. You could see, archaeologically, from Guerrero, we have less than 20 pieces archaeologically. And almost all of them are tiny. And with contextual information, we have nearly 1,000 pieces from Xochicalco. And you could see, if the pieces, when I cast them off, share the same techniques I identified in Xochicalco, they could come from Xochicalco, or at least from epiclassic times. And the problem, the nearly 400 pieces from Templo Mayor, only the first ones, like this one, have the technique of Guerrero. And you could see, for me, quite the same rock. Because they craft greenstone axes. So they modify or recycling greenstone axes or cells to craft these pieces, not like these ones. But you could see in Templo we have huge pieces, and especially these granodiorite pieces that I don't identify there, but maybe this one could be a post-classic object, a Scala style snake, but it's not from Guerrero State because the animal pieces from Guerrero State are tiny, and this is huge. So you could see, we could identify, not all came from the supposed region and period. We could identify maybe formative time, epiclassic times, post-classic times. Also, I could confirm casting them, but you could see that.
in a completely different part of the world, not being familiar with the material culture of Central South America. But am I understanding correctly? Then these are later replicas of earlier cultural
Yes,
cultures?
like emulation of them, exactly.
Okay, they're not contemporaneous. They didn't see a
Yes.
style that they liked with the
Exactly.
neighboring region, and okay, later.
So that's the reason that a lot of people thought that because it looks like from Guerrero, all of them came from Guerrero. You could see, not all of them came from Guerrero and not from the same temple.
Yeah.
We could distinguish from which
Yeah.
period, from which side. And the problem is that, well, I failed with this problem with the famous, without context collection that scholars like Miguel Covarrubias or Carlo Gay employed to characterize the Mezcal style. And it's the Leo Finot collection. I analyzed more than 500 pieces of this collection, and you could see the sizes. Huge. But almost all the huge, like half a meter, are fakes.
Modern things.
Modern, yes.
Wow.
But this is one of the good ones, you could say. And the techniques of Xochicalco.
That architecture is beautiful.
Yes, but it's craft with discs. And the tool is so fast that they couldn't handle with care. And they have some mistakes crafting with the discs.
So what tool were they using?
Metal discs.
Oh, really?
So it's
The
a fake.
modern
It's
version.
a fake, yes, exactly.
Is it at all like similar to what existed, or is it totally?
No, total,
like,
we
it
have,
looks a little Greek, doesn't it?
yes, and with some Moai or Eastern Island inspiration, because
That's
these fakes
amazing.
are so famous in the 1940s when Thor Heyerdahl
Yes.
did and published his book of Eastern Island.
No way, that is
Yes.
fascinating.
But we have original ones, and you could see the Sutherland style pieces, like this one, that are good ones. Yes,
For the larger figurines, like it was the manufacturing technique. that
yes,
gave away the
I analyzed them,
origins.
and they employed, for example, for polishing them, a cerium oxide. And cerium oxide is a rare earth element in the chemical table. It's in the last two lines, a part of the rest of the chemical elements. And cerium oxide came from France, and it's a powder for polishing windows. So they employed, since Manuel Gamio and Miguel Covarrubias times, because also Diego Rivera thought that the contemporaneous mestizo people around Teotihuacan or Tasco, if they craft the pieces inspired in pre-Columbian ones, they are the heroes of those cultures, and in the eyes of these people, like revivals of ancient Mexico. But they are fakers in hundreds of pieces, and Lagma collection, a lot of European collection, a lot of pieces crafted by these modern workshops. And that's the example that because I analyze pieces from Lagma, and this famous Olmec Jabber is beautiful, but it's a forgery, beautiful forgery. I worked with Virginia Fields more than from 2006 to 2008, and she's renewed the exhibit cases, and the famous that opened the Mesoamerican assemblage of Lagma, fake. But they have real ones. The fake, you could see the discs, how the machine is faster than the hands, but also the
So,
suit effect.
a question, how many of those architecture ones do you think are fake versus real?
Almost all.
No.
And there's a book about Carlo Gay, about them, and all of them you could see these lines. If you imagine like you have a CD and put it,
Yeah,
and you could
yeah,
see
yeah.
how to produce these mistakes, you need to employ hours of blades or flakes of
Yeah, yeah.
obsidian or chert to produce this mistake. Hours. In seconds with the discs. because they couldn't handle, because the machine is faster than the eye.
Yes.
But we have one archaeological temple in one of the offerings of Templo Mayor.
So there's one that's original.
Yes,
Does
and
it-
it's three-dimensional, not flat.
Oh, I was gonna ask, is it
Yes.
at all like this? So these flat ones are almost like.
They almost all the flat are, especially of this, the discs. And the three-dimensional, I will show you because I have the three-dimensional.
Oh, you have
the
that
offering.
3D?
Yes, yes.
We're architects over here.
Yes, you will see it. So you could see it. And you could see I handled with collections without context, and I could recover. This is Sultepec, post-classic time, Xochicalco time, Teotihuacan, Olmec, Guerrero style, right? Post-classic time, Chontal, post-classic time, post-classic Mixtec style, another sector. This is after the break, but I think, Mati, we could also have the temple. Remember the Mezcal style temple? Because they interested if we could have it. You could see by this way that despite it looks like the same style, we could clustering better and came from different regions and not from the supposed main region that a lot of the scholars proposed. And also breaking and blowing the mind that Xochicalco, because they have the Xochicalcan style. It's not related with the techniques and the stones with the original Mezcal style pieces. So imagine with that, we're complicated the development of some aesthetics and stylistically by morphology or iconography, a lot of the main Mesoamerican styles. So we have really problems with these materials. And to show you some of them, before we're taking the break, I have some RTI models of some of the pieces, not these ones, but pieces from Templo Mayor or other collections that are related with this. For example, the famous Olmec mask that is not Olmec. As you could see, of my booklet, I analyzed it. We have a tiny group of Olmec pieces from Templo Mayor. Almost all of them craft with blue jade. But there are only 2 of them that are not blue jade. This head, that is like the offering for of La Venta, and this is crafted with Corniana hornblende. It's a really strange rock. Came from Guerrero, and the techniques didn't match with any Olmec object. It matches with Oxtotitlan and Tepantepanitlan, the Olmec from Guerrero. Well, the scholars call them the Olmec from Guerrero. And you will see it's here. And how we identify the techniques of this? Because the Olmec didn't drill with multiple drills to produce the eyes, the mouth, and also we have a glyph in the forehead. We did.
What is it?
You could see it.
Oh.
So with this, we could move. I will show you with more detail. We have some lines, what I have in other images, but I will put another filter. Sorry, it's not this one. Yes, it's normals. But I need to move the light too, because I couldn't move the light with the normals. Okay, it's there. it's not so clear, but you could see some lines here.
Mhm.
So we have another straight line. So we have a mirror glyph in the forehead. So that's the lines.
Oh.
And you have it, but I will try to show better normal. You can see
Mhm.
the line. You have this diagonal line. So, yes, so it's interesting. But I will show you, for example, one of the earliest writing objects in Mesoamerica, the famous Cascajal block, with one of the earliest writing systems in Mesoamerica. And we analyzed the stone because, remember, oh, jaded, come on. We analyzed it and it's serpentine, but weathered serpentine. This is the color. But interesting is that a lot of people, which are the glyphs? And with this technique, we could move it, but I will show you how can we improve the details with this. You could see. But also we have manufacturing traces. These diagonal lines are not glyphs. And to enhance iconography, you could register better
Mhm.
all the glyphs. And we detected some glyphs that no one reported in the Cascajal block.
Look at them all, yeah.
You could see.
Yeah.
And these diagonal lines are not manufacturing traces.
Mhm.
These are manufacturing traces, they are not glyphs. So with this, you could see, we could improve, because this is the common photo if you take the cenital photo of yours.
Mhm.
Oh my God, it's a nightmare to register the glyphs, but with this RTI,
Mhm.
easy to register them. Another one. This is one of the heads or the faces of the Mixtec Penates from Templo Mayor, and we know that this is a mask in the mouth related with Xochipilli, that it has a flower mask in the mouth. And we know with the RTI which of these inside design were crafted first and which are later. You could see. They did first this one and after this and this because the semicircular is interrupted by the later one. So we know this is first, this is second because it couldn't finish good. So we could know which of the designs inside design were crafted first and were crafted later. You could see. But another interesting thing is that if you change the filter, you could see, you could enhance or diminish the traces of the pieces, and despite a lot of people, these are from a hollow drill like drill. These are circular marks crafted with platelets, not a hollow drill.
What do they carve with?
With a blade or of obsidian flake, circular,
Yeah,
circular,
yeah.
and you can see some straight lines here. It's
Yeah.
not a hollow drill,
Yeah.
reed.
Yeah.
So a lot of people, they employ hollow tools.
No.
No.
We have those at Tiwanaku like that too, and it's also with
Yes.
the obsidian.
And you could see this. That's the reason we employed 50 photos, because we could register with great detail So you could see, we could register with very good detail. For example, they prepared some lines, we don't know, to maybe the edge of this inner circle. Some lines, preparation lines for the middle of the eyes to mark the mouth. Some details that without this, I didn't realize they employed. And for example, we employ this also in whatever object you want. For example, tiny ones, huge ones. This is a tiny pendant of a Maya head, jaded, and you could see the same. Could move the light and know which of the lines could be first and which could craft later. And now you could see these are first and these straight and more continuous are later, because you could see how they are overlapping. And to increase the registration of the iconography, you could see first, later. So we know which are the which of the traces craft first and which craft later. So, and we could do this if we could have a black room and with different angles of the light, 50 photos, and with this freeware software, RTI builder from Hewlett Packard. It assembled the photos, but I didn't tell you that we need one of it. A black or red sphere. We employed obsidian spheres for huge ones and tiny needles with red or a black tiny sphere for tiny pieces. No? So because the software registered the direction of the light reflected in these two, assembled all the photos. That's the only problem that you need a sphere, red or black. There's no other, with other colors they didn't work. I will finish showing you the models before we are making a break. Again, you could see complicated iconography of the pieces, but with this technique, you could see you could play with the direction of the light, and you could know that they did first the margin of the eye, and later the ear flares, some of the traces. No? And if you have problems to register the iconography, with this, imagine in the stelas and Mayan writings, Zapotec writing. I think it's a circle or a ellipse or a rhomboid. Avoid the speculation. Just drawing directly on the objects, on the photos of the objects. And remember, we could increase the register on the order of the manufacture. For example, you could see they did first this part of the headdress, and later they did this circle, because this circle is over this one. So we know the order of some of the size designs. Here it's better, how it's invading this circle. So you could see the potential of the technique. And another thing is this filter, the specular enhancement. If it looks like shiny, silverish surface, maybe 99% of the time it's jaded, because jaded is so reflective. And serpentine and others are more like cold, absorbing the specular filter. So you could see more opaque. This is travel, and I chose this because it's from the same source, banded travel. And it's not from the Cali. And again, and remember, these needles with this tiny sphere, because these pieces are so tiny, so a huge obsidian sphere is bigger than the object, so we try to employ little pieces. And again, you could see which of these lines were crafted first and which crafted later. So, you could see
Yeah.
one, so that's the reason. And the movement of the abrasive tool. They moving in this position, abrading the object. Because you could see the horizontal, in this case transversal lines of the manufacturing traces. You could see better of the manufacturing traces. And as to the other objects, we could employ different filters. Okay, if you are moving, you could register better all the and also some fractures for restorators to prevent the damage of the objects. So it could be good for registering the materials. There's only 3 more models before we make the break. This is a tears sector, and again, you could see moving. You could register the direction of the traces and which of the lines they did first and which are later. Again, you could register more detail. So you could see, for example, this line is over this division. So you know they did this after this one.
Yes.
So we could know and identify some mistakes of manufacturing of the objects. Okay. Yes, this is beautiful. This is like these ones. And again, you could see what they craft first, the triangle of the nose and the mouth, and they did the other facial features later. Let's see. This is first, and after that. Also, they did first the division of the legs, the trunk, the neck, and after that, the arms. So, with this technique, we could know which of the traces were crafted first and later. And the iconography, we want to register. And you could see how many times, remember the tiny model, to produce this you need hours. So, you could see this without that failure or mistake, because this could be a good one. Because this is granodiorite. And this is the material that I will show you later.
Is that real or not?
I think it's good because it's more 3D. And the archaeological one I will show you in one of the 3D models that I will show you later. I have, well, in this offering of Templo Mayor, that's the only, these models archaeologically found in a pre-Columbian context.
Really?
Yes, and it's not from Guerrero, it's from Templo Mayor.
Wow.
So, because it's the same material, a volcanic green lava, I think it could came from.
Do they think it's representing architecture that was at the Templo
Yes.
Mayor? What, if anything in particular?
They craft these shrines at the top of the pyramids.
So for one of the...
See the tiny shrines
like
at the top.
Tolok or the...
Yes. And why I think it came from Templo Mayor? Because in the first decade or years of the 20th century, when the workers of the pipelines digging in front of Templo Mayor, despite they didn't know this Templo Mayor, they changed the name of Guatemala Street to Escalerillas Street, and Leopoldo Batres, the archaeologist in the time of Porfirio Diaz, publishing every day in the newspapers all the findings. And you saw a lot of temples, masks, figurine bits, but the National Museum of Anthropology, you couldn't identify almost all the pieces. We don't know where they are. So they dismember them. Some are in Lagma, some like
Wow.
this, others in European and American museums, because we are tracking all the photos of Leopoldo Valdez, and less than 10% of all the objects exhibited day by day we could identify in the collection of National Museum of Anthropology. And in Templo Mayor Museum we don't have anything of that collection, because Templo Mayor Museum is from the project Templo Mayor in 1978. So this is 78 years before Templo Mayor project. So we don't know where they are. We know that some of them could be in Lagma, like this one, in Europe, because who knows what happened after Padres took the photo. They dismember selling whatever they want to do with that. Because in those times, it's complicated to control all the workers not stealing. I want this one and the other one. So dismembering the collection, and especially the rocks, because these rocks are not the Guerrero stones. You could see totally different.
Yeah.
That's the reason. So you could see, and I
Can I
wish-
look at that?
yes,
That's so neat. What's light?
and the last one before the break is another figurine, I guess. Yes, and again you could see which of the lines they did and corrected the neck. So we also identifying some problems when they're crafting materials. So it's interesting. And remember, when it's not jaded, it
Yeah.
absorbs the light.
Yeah.
It's not reflecting like a mirror,
Yeah.
because this is not jaded. And you could see they corrected the lines to craft, and you could see this was first, and this is invading this
Yeah.
line. So we know which are first, which is second. And to improve economy. So, and some mistakes or preparing designs that we don't know what happened, but you could see.
Yeah, nice.
So it's like lines for preparing the anatomical proportions. Without these filters, I never see we detect that, oh, we have these details. So we recover some info about the crafting, or you could see, so it's not in the middle to the division of the legs. So some mistakes. And because this is not with bilateral symmetry, this is not from Teotihuacan, because the Teotihuacan people are really, really square minds. So with this detail, this looks like Teotihuacan style, but not Teotihuacan people crafting it, because we don't respect the bilateral symmetry. So these details we recovered in the pieces. And you could see, none is like this. There's no golden measure, despite some of them could have bilateral symmetry. And how we know they could came from Guerrero State? Because in Guerrero State they loved short legs. Because in pre-classic times, the people from Xochicalco and Cacachla love long legs. So that's the reason. And also, remember recycling greenstone cells or axes. That's the reason that if we could, a lot of people, they are from the same style, same time period. No, different time period. And that group, I think, no, they didn't come from Guerrero. So we take a break, but if you have more questions, we could. Before we're handling the other jewelry, and I will show you how can we track their provenance. So, thank you for returning and attending the workshop. I hope, well, could be open your mind in the case of the mezcal style pieces, but now we're moving on obsidian jewelry from different time periods, and I will try to convince you from not only which time period and culture, sometimes from which specific site could come the pieces. Also, I will show you how I cast the molds, and I will take some of them. Also, I will let you to cast molds, and I will analyze them, and I will return to Mexico and confirm if the labyrinth, for example, these labyrinths or lip blocks came from the specific site I proposed. No? So, in this case, well, we were moving on obsidian jewelry. Now, this is a glimpse of the different objects that Lisa sent me to handle and talking about. So you could see we have different, like pendants, eccentrics, beads, another kind of eccentrics, another pendants, labyrinths or lip locks, and another kind of eccentric. But you could see, fortunately, the photo you could appreciate the green golden obsidian that came from only a unique source in Mexico. It's Sierra de las Navajas or Sierra de Pachuca. It's a famous from along Mesoamerican cultures. They like this because it's a unique color of obsidian. But we have also translucent gray, mainly from Pico de Orizaba or Paredon, the source Tres Cabezas, and we have other grayish obsidians that could came from West Mexico, so Central Mexico. So in this case, we need the techniques like XRF to confirm the grayish colors. No? So, well, after the glimpse, we will move in on specific groups. And when Lisa sent me the photos, I told her, oh, this came from West Mexico. How do you know that? I saw Rodrigo Esparza, a friend that works in Colegio Michoacán. He worked with John Clark with some of these Teuchitlan pieces that came from West Mexico, from the state of Jalisco. And you could see it's the same obsidian, and with the same elongated shape. So you could see this one, and we have from Teuchitlan, it's broken, but we have the same elongated. And interestingly, when you could come close, all of them are in grayish obsidian, and some of them is banded, so it could come from Ucareo. So West Mexico, grayish banded obsidian, same shape, same features, elongated features, and with the obsidian that mainly, I think they came from West Mexico. And almost all of this kind of jewelry came from Teuchitlan or Huachimontones culture in the highlands of Jalisco. And this site is from formative period Mexico. So they could have at least 2,000 years of people craft these objects. And interestingly, if we could take the molds, we could know if they employed chair drills and abrading with dacite or with rhyolite. For example, that's a common tool in the part of West Mexico. Remember, I didn't tell about dacite or rhyolite in Mezcal style or Mexico, Tenochtitlan techniques, also Chicago techniques. They employ basalt or andesite. In West Mexico, they love rhyolite and dacite. So, cultural preferences in specific tools and raw materials, we could track from which culture, region, or also sometimes site the pieces were crafted, because they preferred one stone among others in the case of tools for abrading, cutting, incising, polishing. But we have, after these pendants, that we have 3 of them, all of them, when you take a look on them later, we have these interesting pieces crafted in obsidian, and again, it's banded grayish obsidian. Maybe they came from Ucareo, and you could see that with a wider width of the handling part, It's more common in some salvage archaeology in the surrounding of Zapopan. Also, but the problem with this northern Mexico is in this famous book of Obsidian and Crystals in Mexico by María Carmen Serra Pucha and Felipe Solis. A lot of pieces are without context. In the collection, they came from northern Mexico. But archaeologically, we have some examples from Zapopan side, and in the case of central Mexico, you could see it's so thin. So I don't think they came from central Mexico, and maybe they could come from West Mexico. And well, if we take seriously these unprovenance pieces from the National Museum of Anthropology, could be northern Mexico, but I prefer West Mexico because especially the banded grayish obsidian that came from Ucareo. And it's related also for formative times, in the case of this salvage archaeology. But we're moving in a more complicated objects that we have, for example, these eccentrics in the shape of animals, these discoidal beads, and this like W or M shape that is related with, some scholars talk about the mustache of the rain god, the Tlaloc. Also this semicircular eccentrics, and some zigzag or well, the zigzag or the body of snakes that could be related, and this is in the shape of a snake, that could be related with eccentrics of Teotihuacan side. You could see some examples from Pyramid of the Moon, the Temple of the Feather Serpent, some exhibition from David Carballo, or reported in different sectors and neighborhoods of Teotihuacan site, also from Pyramid of the Moon, or by Serra and Solis from different assemblages that the National Museum of Anthropology have it in the Teotihuacan exhibit hall, or the Pyramid of the Moon by Sugiyama, and from the excavation of Linda Manzanilla in Xala and Teopan Casco, we could see the same beads with the same color, the green golden color, and they craft them by, you could see the edges, they craft by drilling obsidian lakelets. So they craft by the same original piece of obsidian in the same color, and in the case of these W or M shaped eccentrics, the size is more related with Teotihuacan pieces, because I also analyze pieces of this shape of Teotenango, but they are micro M or W. So tiny that I need this kind of device or tool to take them, and in this case they are bigger ones, and we have green golden, but interestingly we have grayish pieces, in grayish obsidian. So the grayish obsidian, I know that in Teotihuacan also we have some pieces in grayish obsidian from different sources like Otumba, Socualtipan, Tulancingo, but they need sourcing the materials to confirm if they came from obsidian sources from central Mexico and not from West Mexico, because if they came from West Mexico, it could be another site of origin of these pieces. In the case of these objects, almost all of them, only one or two are in grayish obsidian. Also we have these kind of pieces in different parts of Teotihuacan site, bigger ones that you could see by Solis. But interestingly, we have one brownish obsidian eccentric that is different in size and shape, also in the source, and there are reports of them in Tula site. So this could be a Toltec obsidian, and about 500 years later than the other part of this collection. So it's interesting that you could see in the same group, close the same shape, but different obsidian, different shape, and different time period and culture. So we could distinguish them, and especially for me is this that they craft based on lakelets. They fragmented them, drilled them, and working like in the collection of the Katrin Institute, like the same. And we have dozens of them in some parts of Chala and Teopancaso site, neighborhoods in Palace Compound and the Rigogan site. Also, it's interesting, this particular object, that it looks like a fish hook, but it's not a fish hook. It's a labret or lip lock, and we have in shell and in obsidian from Templo Mayor and from Central Mexico collection of National Museum of Anthropology, but I think it's not from Central Mexico. Or why I think that? Because this kind of labret, you could see, it's common among the Huastec people, the Huastec warriors. It's a jewelry, fashion jewelry, that like an ethnic identity. Justina Olko is a scholar from Poland that worked and wrote a lot, 2 books at least, and some articles about costumes, jewelry, and regalia among post-classic Mesoamerican cultures, and she proposed that it's related as an ethnic identity jewelry from the Huastec region. So I think these pieces, despite we have in central Mexico, you could see Mexican or Tenochtitlan warriors capture Huastec people, and maybe the finding of 2 of these labrets in central Mexico is because they are from captured Huastec people and brought them to central Mexico. And it's interesting that in the market of Tlatelolco, that coming pieces from long distance goods from all around Mesoamerican cultures, they offer these labrets to the ruler of Tenochtitlan, Moctezuma II, but they thought that they came from the Huastec region. So I think that this could be from the Huastec region, but there's only one possible second origin of the objects, that in this case, the Codex Tejerano-Remensis told us that this is not a Huastec people, this is a warrior from Huejotzingo in Puebla Valley. But the problem is that we don't know, it's the only image that could be from the Huejotzingo side, because it's common that an attribute from the Huastec warriors is this hook shape of labret. So for me, it's more probable to be a Huastec jewelry than, because it's the only image of this kind of labret. I'm supposed to be from Huejotzingo, but we don't have any proof and any other independent image that could be from the Huastec, from the Puebla Valley. And these are from different codexes, and they agree that it's a Huastec attribute from the warriors. And also, sorry for that, also in, I didn't obtain the image, but one of my students worked on the jewelry from Tancama. It's a Huastec site in Sierra Gorda of Querétaro, and in this shape, but not so long, she found one fluorite hook-shaped labret. So another Huastec site with this shape of labret. So for me, it's more common in the codexes archaeologically that you could see these 2 sources of information. We have these labrets among Huastec people. And one of the most common objects, but with a lot of complicated origin to track from where they came, are the labrets or lip-locks. So you could see we have a lot of them in the collection. When you stand up and take a close, and I pre-divided them by the colors. Some of them are in green, golden obsidian. Others are in transparent, like ice obsidian that came from maybe for Pico de Orizaba. Another are grayish with banded obsidian, maybe from Bucareo. So, and some of them are so thin. And you could see with the comparison labrets or lip-locks that I have in my experience, the thinner ones, could be these 2 ones, are quite the same from Tlatelolco. So they could make, I need to check if they share the same techniques. We have also some flat drill pieces, like from Texcoco, the Coloacan people. We have other ones more rounded and more with a wider width, so that could came from the Chalco, Mecamecan, and Mixquic region, and grayish color, and we don't have anything with banded obsidian that came from Tlacopan. And we also don't have any from the Tarascan, from Sinsunzan, but the grayish ones could be from another culture or site from West Mexico, because it's common, this kind of labrets would craft in grayish obsidian from the highlands of West Mexico. So you could see quite the same object or jewelry, but different sites of origin of the pieces. So same object, different culture, and different techniques that we could cast them all and confirm from which site they could come from. After I finish some slides, you could stand up and take a look at them, and we will also look some details of this jewelry in the dynamic microscope to appreciate better these details. And another problem is, remember, more simple objects, more complication, because greenstones, a lot of cultures employ them, but if you could see, Chiapa de Corzo, the same shape, also some of them are crafted in jaded, like this one, from formative time. It's not common in La Venta, another famous Olmec site. And for example, another culture in the Guerrero state, they craft a lot of axes, but you could see with another shape. So for me, this could be from formative times and could be from Chiapa de Corzo if it shares the same or matches the same techniques that we identified in the Chiapa de Corzo greenstone that we analyzed of the excavation of Lynette Lowe and Bruce Bachand, of these famous burials that have dozens of greenstone cells. And especially these three ones have quite the same size and shape of this greenstone. And they employ sandstone and coating with obsidian, polishing with leather. In the case of the Olmec people from La Venta, they employed only sandstone and leather without cutting any of the edges. In the case of the people from Guerrero State, they employed andesite, coating with chert and polishing with chert pebbles. So, depends on the techniques we identify here, we could confirm or discard the probable origin from Chiapas, from Gulf of Mexico, or from Guerrero, for example. In the case of Central Mexico, they prefer to operate in the greenstones with andesite. So, the technique could track from which part of ancient Mexico this greenstone could come. And we have two of the last objects, or three of the last objects. These discs, obsidian disc, maybe mirrors or pendants. You could see it's a grayish banded obsidian, so it could be from West Mexico, from Ucareo, and it's more common, this kind of objects, in among the Purepecha, because if it could come from Central Mexico, from the Mexica or the Tenochtitlan culture, they employed green golden obsidian. So it's not green golden obsidian. Both the Purepecha and the Nahua people loved discoidal mirrors in obsidian. So because of the color of the obsidian, I think it could be from the Purepecha and from like the Tzintzun's and objects. And finally, this curious object that you could mix or join both of them, maybe for smashing something, maybe pigments here. This kind of rock, it's a metamorphic rock, maybe gneiss or skarn, depends of the analyzing them could distinguish which of these two stones could be. I think it could be skarn, gneiss, but we need to analyze in detail. we have some kind of these objects with this rock in the Acoloacan region close to the airport that the government of Mexico canceled in Texcoco, and it has the same rocks and the same idea of crafting in metamorphic rocks, huge hollow materials like this, maybe for smashing pigments, or this jar. And inside it is like the same in this case of this. So for me, if it matches the techniques of the Acoloacan pieces, could be from the Texcoco region. And you could see another, so you could see these greenstone spots of the material that we have in the case of pieces from the Texcoco region. So in conclusion, before we are handling the materials and looking or taking a close detail with the microscope, obviously at the beginning we discussed the advantages and limits of different equipments for characterizing the raw materials. Obviously, when we want some info, depends on igneous rocks, sedimentary rocks, metamorphic rocks, the techniques could be related with what we want to know. For example, XRF, it's very good for sourcing obsidian, but not for greenstones. We employed Raman or EDS, micromicroprobe, to detect sodium, for example. In the case of the traceological analysis, we could improve the accuracy of tools and techniques by analyzing not only with the optic microscopy. You could see, we could fingerprinting the traces with scanning electron microscopy, and with that, comparing the major trends or patterns, and the whole assemblages of the specific regions and time periods, we could identify the styles and the provenances of the pieces, despite we don't have the info of archaeological excavations. By this way, we could recover some info from pieces without context. And well, this wouldn't be possible with the participation of different colleagues and institutions. And thank you so much for the attention, and we could take we could stand up and handle the pieces, and we take a look on the diode microscope to see some details of the manufacturing traces of this obsidian jewelry and some of the pieces that we saw before the break. Thank you so much.